It was very loud though. And that was 5 years ago? Wasn't it eighth grade or seventh grade? It definitely wasn't high school, but it was.
What happened to your calculator?
We were talking about bringing a calculator to class.
What's the problem?
I don't know.
She ran into it, guys.
Well, it sounds like a
I
personal
did, I
problem.
stubbed my toe.
Ouch. The guy who designed the Brooklyn Bridge, that's how he died.
Stubbing his toe?
Yep.
How do you die studying your toe? What do you start?
So back before antibiotics, right? Or this was before a disease called, is it the disease? It's tetanus. You get tetanus shot every 10 years or so. I believe it's a bacteria, but anyway, it causes lockjaw, and he died of lockjaw. Lockjaw is a symptom of the disease.
The guy who made Lucifer up in the Denver airport actually died by getting crushed by.
No, he did, and
Yeah,
that's
he
gotta
did.
be lies.
That's why the eyes are red. So the eyes were never supposed to be glowing, but he was building it and they were putting it on there, and it wasn't stable enough, and it fell straight on him, crushing him. So they put it back on there and they kept it where it was, but his eyes were supposed to be just a normal black, but they changed it to a glowing red because it killed him. So it's just a
If I had a BS flag, I would floor it right now.
Google it.
I'm going to, but not right now.
Google it.
One time I went up to pick up my wife from the airport from Denver. She flew into Denver, and I brought my dog with me, and the dog growled at the blue.
Lucifer.
Yeah.
That's cursed. What? The blue horse.
When you go to Denver International Airport, there's this crazy Denver Bronco blue horse, right?
It's cursed.
All right, how'd that homework go?
Okay.
Are we supposed to get this?
You should not have gotten any decimals. No. I was just checking to make sure I was recording. I am recording. Okay.
All right. Well, we are rapidly winding down to the end. All right, so seniors got to help me out. Again, I just want to reiterate. For seniors, we're gonna stop chapter 11 test.
Okay.
Right? And then I'm going to hand you packets on Wednesday, but you gotta tell me you were supposed to say
Thursday.
you're gonna take the test on Thursday. That means 1 day review?
Yep.
Priscilla,
Me
are
and
you
Priscilla,
crazy?
me and Priscilla won't be here next Tuesday. No, they won't. We have a track meet.
Yeah, my band.
You gotta take your test on Monday. I'll give you
Can I,
the review packet on Friday.
yeah, but can I have an actual review 7th period then?
Sure.
Okay.
On Friday.
Yeah, I'll do that.
Okay. we
Oh,
can do
wait,
that.
won't be here Friday.
Who won't be here Friday?
Us.
Oh my goodness.
How about
Senior
Thursday,
breakfast,
please?
yeah. You could.
Well, I'd have to give you a different test because you're not gonna get 11-7.
You could
Okay.
come in during after senior breakfast.
I won't have a
I
ride.
have to go on Tuesday.
You could walk.
I mean, like home after.
But you're literally saying you want the test on Thursday?
Tomorrow?
Are you
No.
hearing this?
No.
Your
They
final.
want they want the final Thursday.
No.
If you let her speak for you, seniors,
No.
this is when it's gonna be.
No.
I don't want that on, I'd rather take it on Friday, on the last day we have to be here.
Which what?
On the last day we have to be here. I'd
Because if
rather
not,
take
we
it.
have to sit
You
here.
won't be here Friday though.
I know, that's why.
Which Friday are we talking about?
Both Fridays.
Why not this Friday?
We have a track meet that day too.
What time are we walking out?
Don't know, but we are gonna leave at like 7.
Okay, well then,
Because that's when we walk out. When you guys walk out,
No,
and go to
No,
that track,
before
you
we won't be here, but like
No,
when
we-
school starts.
Hey, juniors, if you make it this complicated next year, I'm gonna fail all of you.
I will have
an A in your class, so I won't even have to take it.
We have to walk out.
Yes, but,
I don't know.
we were told by Miss
They're
Coleman
so
that the rest of us.
Clearly, we need to give this some more thought, these mechanics, so this works.
Blame
Uh,
Mr. Markle.
The two non-negotiables are you gotta take the chapter 11 test and and if you don't have a B or an A, you gotta take the semester final.
I just wanna have 2 days to
Just
practice,
practice,
to
yeah.
have practice.
I'm
for the
with you.
semester final.
Can you come in? I will be flexible and offer my time if you want to come in at a different time. You can take the final on your bus trip to your, I'll let Markle take the test with you. You can take it then.
Okay, well, actually, I don't care when I take the test,
Oh my god.
but
I'm going to strangle you.
because I won't be taking the final. So,
Well, you have to, yes. Well, I would say, not to say your grade on a recorded thing. I know what your grade is right now, and you are,
80%,
I thought it was 83.
it went down one.
That is
Right.
dangerously close.
You
Yeah,
are,
I would-
you are rapidly approaching, depending upon what you get on this test. I don't know, I can look up what your test average is. If you get chapter 11 test lower than your current average, then that's gonna drag that 83 or 82 down as well too, so be careful.
I have a great test.
Copy down your homework. Clearly these are gonna be much more complicated. There's only 5 of them.
I'm gonna cry. Yeah, I'm done.
So, tomorrow I can come in 7th period for a review.
Who do I hang
Yes.
out with?
I will too.
You yourself.
And then take it
And on Monday,
Monday,
while they're doing their review, you're gonna be taking the test.
okay. Sounds good to me.
And then juniors, you better not make it this complicated next year.
Well, you can have them to
take it.
So just don't do track.
Just don't do track.
Hopefully.
None of them are in track anyway. So no, that's what I'm saying.
Don't do track.
Do you think I could pass calc with an A?
If you put as much effort into calc as you did in this class, you will not notice any difference between calc and pre-calc. It will be as challenging. If you thought this was crazy challenging, then it's gonna be crazy challenging. If you thought this was, okay, it was more challenging than the math classes, but I did fine, then you'll be fine.
So minimal effort.
If you put minimal effort into this, I'll just say then you most likely could do minimal effort into calculus. Because how much weird stuff did we do in this class that you've never learned before?
A lot.
A lot. And that's what's going to be like in calculus. There's going to be some familiar things, but there's going to be mostly unfamiliar things. And if you're okay with handling new stuff, then you'll be fine. I did not think that calculus, I mean, teachers always talk big smack about calculus. And yeah, for normal people, average people, calculus is challenging. But for math people, it's not that challenging. I don't want to say it's a pushover. If you blow it off, you're not going to get it because it's weird stuff. But it's also not very challenging math. It's just on the same level as pre-calc. All right, here we go. Second part of the class on partial fractions. Partial fractions is used in calculus to make your life a little easier. It's not calculus, partial fractions, but it's a step in doing one of the 2 things you do in calculus. It's hard to see why it's useful until we actually get into calculus. And usually we say, hey, you got to solve this. We use in partial fractions. Kids kind of freak out a little bit because they remember the more challenging ones. They don't remember that most of the time. Today are medium ones. We're not doing a really crazy challenging one, but they're kind of medium, right? Trig always elicits groans, but partial fractions shouldn't be that something that you're intimidated by. All right, so let's see. Partial fractions. If I take a fraction and add or subtract it to another fraction, I get a different fraction. And I get that different fraction by creating a common denominator, multiplying both fractions by the common denominator, and then adding the numerators. That's how I get to this final answer right here. What partial fraction does is the reverse. Partial fraction says we start with the solution, in this case, 5x minus 1 over x squared plus x minus 12, and we turn it back into the original 2 fractions. This is called partial fraction decomposition. We're turning red into blue. Usually we're taking blue, turning into red, but if you do what's called partial fractions, you're given the red and you turn into blue, and we did these yesterday. All right, so remember the steps that are in front of your face. Step one. We don't worry about the numerator. The only time we would worry about the numerator is something canceled immediately. They should not hand you a fraction that needs to be immediately canceled. So they're handing you a fully reduced fraction. First step is to factor the denominator. All right, factor the denominator. Go.
1 and 6.
1 and 6, but it's -5.
And -6, +1.
Okay. I think it's -2, -3, but let's see if your math works.
Why not?
Well, the 6 has to be positive.
It was negative.
And if it was go ahead. Go ahead. We were talking over each other.
Oh, if it was
Oh.
-6, then yeah.
Yeah.
It's just one way to factor.
If it was -6, she's right. It would be -6, +1. But it's +6. Negative times negative is positive. Okay. What do we do with this? This tells us how many fractions we're going to have. How many fractions we're going to have. How many factors are right here? 2. So therefore, we're going to have 2 fractions. We also look to see if there's any powers outside the parentheses. Any powers outside the parentheses? So this is flavor 1, as we said yesterday. That means there are no repeated factors. If there was an x-3 squared, or quantity x-3 squared, then that would be a repeated factor, an x-3 and x-3 squared. But in this case, none of them are to a power, so we have no repeated. This is flavor 1. So we simply set it up like this. We take one of the factors, x-2, assign it a capital letter A as the numerator. We take the second one, assign it to as a numerator of B. Those letters are whatever letters you like. They also don't have to be capitalized, but we usually make them capitalized. Okay, next step, step 4 is we clear the fraction. We multiply everything by the common denominator. And when that occurs, well, we don't have fractions anymore. The remaining steps, I showed you 2 ways of doing it. The remaining steps are we got to find out what A and B are. If it kind of looks like this, where you have an A and you got a fraction or a parentheses, and you got a B and you have a fraction, and the numbers are different, it's usually easiest just to substitute numbers in to make one of those variables go away. What are we going to substitute? We're going to substitute a 3 or a 2, a 3 or a 2 in any order you'd like. So if I let those X values, everywhere I see an X, I'm going to write the value 2. So I took this thing right here, where everywhere there was an X, I wrote a 2. And the magic is that if you look over here, that B times 2 minus 2 would be literally B times 0. In other words, that would go away. 2 minus 3 is -1. So we get negative A is equal to 2. In other words, A is equal to -2. I know what A is. A is -2. To find B, we do that same process, except I need to get rid of A. To get rid of A, I'm going to let all the X's be the value 3. 3 minus 3 is 0, so the A goes away. 3 minus 2 is 1, so B is equal to 3. We take these 2 answers here in yellow, place them back into the original equation that we set up, and that's your answer. And once that's, again, I said the book will typically take that -2 and put the negative out front. And that was half of your homework. Yes, everybody? Okay. The second flavor is when you had repeats. And if you notice now, well, the denominator is already factored for us. It's got a square on it. So what are the repeated factors? The repeated factors are x minus 2 and x minus 2 squared. In other words, I take this 2, I subtract 1 from it, so I get to the power 1. And that's your first factor, because x minus 2 goes into x minus 2 squared. And then x minus 2 squared goes into x minus 2 squared. So I have 2 factors. Those are your 2 factors. The rest is the same. One of them gets an A, one of them gets a B, and then I just go to town on it. I clear the fraction, so I'm going to multiply the left side times x minus 2 squared. I'm going to multiply this fraction with the A in it times x minus 2. That's what I'm missing. And for the B fraction, I'm not missing anything, so it just goes away. Seth, what I'm not showing you here is I'm multiplying every one of these fractions times x minus 2 squared. So that would cancel, that would cancel. On this one of the x minus 2's on the bottom would cancel, but I would still be left with 1 on the top. Okay, I showed you 2 ways of doing this. First way was doing a substitution. The second way is kind of do some arrangements. In other words, I can either plug in a 2 or I can distribute this A to the inside. I'm going to show you the method. This is the one I'm going to use today, most likely. I'm gonna distribute this a to the inside, so that would give me ax minus 2a. I put parentheses around the a and the b, and I look at the left side. The left side says 7x minus 11, meaning the number attached to x has an equal sign. The number attached to x has to be a 7. Well, the number attached to x on the right side is an a. That means a has to be the value 7. So a has to be 7. And then what's inside parentheses must equal negative 11. It's an equal sign. So the left side must equal the right side. Right? So if that equals negative 11, I set that just this portion, negative 2a plus b equal to 11. But I know a is 7. So that would be negative 2 times 7. I got to sneeze. Agreed. So therefore b is equal to 3. Thank you for taking over while I was sneezing. Cool. Now I showed you two techniques. One where we do some substitution, one where we do this technique. This technique I showed you, it doesn't really have a name to it. I'm going to use for every single example today. It will find out for the day's ones, it's easier to do it this way. Final answer looks like this. Okay. Turns out I didn't tell you the complete story yesterday. I said I wanted to teach you the nice easy ones first. It's not that this is the hard one, it's just this one requires the most work. Okay. Turns out there's a different flavor than what I've shown you. Everybody paying attention? It doesn't look like. Every single example here on this slide right here, x is to what power? X is to the first power. Is it possible that x could be to a different power? Yes, right? So the more complicated ones are when x is not to the first power. Since x to the first power is what's called a linear equation, these are all described as linear factors. It simply means the x inside of the parenthesis is to the first power. If x is inside the parentheses, but it's not to the first power, then it's not linear. We need another recipe or final recipe. Okay, so every one of those x is to the first power, we use the technique, hey, repeated or not repeated. Right? The last and the final technique, right? What if they're not linear factors? What does it look like? And how do you take the partial fractions? Okay, so these will be, you'll see they're logically a bit more challenging. I'll try to walk you slowly through them, right? Usually we get groans at this point. These will be the most challenging ones. All right, so it says find the partial fraction. Okay, step number one is we still have to factor the denominator. Anybody remember what this factors to? X cubed minus 1. It's perfect cube. Anybody remember? Well, we could do some long division. X cubed plus 0x squared plus 0x plus 1. What do you think goes into it?
1.
So in other words, x plus 1?
Sure.
Or x minus 1? Which one do you want? So let's see if x minus 1 goes into it.
Oh, you put plus 1 instead of plus 1 on the x.
Oh, I did. Thank you. It just would not have worked. Okay, you're on. Go. X squared. Thank you. So that would be
0.
minus.
Yeah, but it cancels with x.
That times that is not 0.
Minus x squared.
Minus x squared. X cubed. Change the signs and subtract, or add, sorry. So we get x squared plus 0x. All right, go. So remainder of 0. So it's x minus 1 times that right there. Ish, I'm sorry you couldn't see that, but I just factored that on board. And by the way, Ish, this is the one that you and I did when you got help yesterday. X cubed minus 1, or maybe it was x cubed plus 1. It was one of those two. All right, so the bottom, when we factored, we got into that. Yes? Cool. What do you notice is different this time? No, there's not two numbers multiplied by 1 to add 1. What's different now?
There's it's a trinomial.
This one looked fine. It's not that it's trinomial. What's different? I got an x.
And then
Got an x squared. That's the problem. So I don't have a linear term now on the inside. Yes, trinomial as well too, but I don't have a linear term. If it was just another x plus 1, we'd be fine. But this time I have an x squared, so that's a non-linear factor. So we need new magic, right? All right, here's the new magic, that x squared. It's going to look very similar. It's just we're going to add something, okay? Notice that neither one of the parentheses is to a power, right? Or so it's the power 1. It's not, the parentheses aren't square or anything like that. It would be repeats, okay? All right, so here's how you hit it. Here's the new medicine, the new recipe. X minus 1 is going to get the A. In the previous technique, then the second one would get a B. But because inside the parentheses there's a squared, we subtract 1 from the power. 2 minus 1 is 1. And I put an X. If this had been a 3, we would do 3 minus 1 is 2. So I'd have a bx squared plus cx plus d. You're always going to go down by 1. Tonight for homework, they're only ever going to be squared. So it's always going to be a letter times x plus a constant.
So it's going to be 1 less than the equation.
It's always going to be 1 less than that right there. Like I said, technically it could be a 3, so you get a bx squared plus cx plus d, but not in this case.
If the bottom has 3 terms, the top will always have
Yep.
2.
Yep. Yep. Yes, that is true. No, that's not true. Because if this had been an x cubed plus x plus 1, it still would be bx squared plus cx plus d, right?
Yeah, but technically there would be.
But if it had been a 4 or something like that, then it wouldn't have 3, it would have 4. I'm sorry, it wouldn't have 2, it would have 3 things. It's always going to be 1 less than that's going to be your starting point. Okay, so that's the only change right here. Everything else is done exactly the same. All right. The problem is now we have an x in the numerator, and that causes problems. Right. But the process doesn't change from what we did. We're going to basically clear the fraction, and then we're going to do some algebra magic to get to the answers of what A, B, and C are. Okay, so let's clear the fraction. We clear the fraction, what do we get on the left side? It's always just going to be the numerator. Okay, now we've got to be careful. On the right side, what is the first fraction missing? Here's the common denominator, x squared. So that's going to be attached to A. What's this missing?
X minus.
Ooh. It looks easy, but this is what's going to add the complexity. Okay, so we got truly a hot mess now. The technique I'm going to suggest to you, this particular one, it could be done by really thinking hard and substituting some numbers. I'm going to show you the second technique to show you how a little bit easier it is. This one will require a little bit of thinking of what values you got to throw in to make it work for you. Well, that's going to get you to the A, but finding out what B and C are is a little bit more complicated. But you could certainly find A very quickly. And you could also combine techniques if you like. You throw in a 1, find out what A is, and use that for the second technique. All right, here's what I'm going to do. I'm going to suggest you actually just do the math that's in front of you. Distribute the A and multiply these two together. If we distribute the A, we get plus A. Okay. This one a little bit harder to do in your head. Bx times x.
Bx squared.
Bx times minus 1.
Minus bx.
C times x. And c times negative 1, and we get that. See what I got? There's your first part. There's your second part. Okay? All right. Now what I want you to do is I want you to group like things together. I want to group your x squares together. I want you to group your x's together, and I want you to group your constants together. Okay.
Plus ax plus bx plus cx.
See what I did? And then I factored out the constants. That's the a's and the b's and the c's. So if I group the x squares together, Abby said it's ax squared plus bx. That means a plus b times x squared. I'm doing 2 steps at once. If I group the x's together, I got an ax, a minus bx, and a plus cx. So if I factor out an a minus b, and a c, I'll be left with x. And the last one, the constants, that's just a minus c. See what I did? Watch this magic. I find this easier than trying to, okay, I can see there needs to be a 1 there, but then the rest of the numbers are hard to figure out. If I look at the very first thing on the right side, it says
A plus B times.
there's no x squared on the left side. So what's that tell you what a plus b must equal? And
So-
it tells you that a plus b must equal 0 because there's not an x squared on that side. So I can immediately write, I'm going to make all this go away for a second. Here's that statement again. So I know that a plus b must equal, it's really slick. I know that a plus b must equal 0. There's no x squared on this side. Further, I know that a minus b plus c must equal, and I know that a minus c must equal.
Negative.
That was really quickly done. You don't need to put the spaces like I did, but I put them there for clarity. Do you see how I got that? And that's all because it's an equation. Okay, now we just do some math, right?
Can you explain that in a different, other than that?
Okay, I'm going to erase all that right there and ask you what it says. That means on the other side, what must it say? Because it's an equal sign.
Okay, no, but like. Can you explain?
I'm just saying.
Out.
It says 3x minus 5. What must it say on the other side? It must say 3x minus 5. It's an equal sign.
That doesn't make sense right now, so I'm trying to ask if we.
Does 4 equal 4?
Yes, but can you explain it in another way than it being slick?
The left side must equal the right side if it's an equality. Well, I'm not sure how I can explain that
It's
differently.
fine, keep going.
Okay, this is slick. It's not an explanation. It's a comment, right? Since there's no x squared over here, that means a plus b has to equal 0 because the left side has to equal the right side. So in other words, there can't be an x squared on either side. Well, if you let a plus b equals 0, then that gets rid of your x squared. And since there's an x right here, that means that x has to equal this 3. So a minus b plus c has to equal 3. And since these are the constant terms, a minus c must equal -5. Okay, now we're going to go to town on these statements right here. Here's the first thing I'm going to do. I'm going to take those 3 statements, and I'm going to solve for a letter, any letter that you choose. I'm going to choose the top one because I got a 0 and that makes life easier. If I move to B to the other side, it says if you see the letter A, you can write -B. Well, I see lots of A's here, but instead of A now, I can write -B. So I'm going to take this second statement. It says A, but it says if you see A, you can write -B, so I write -B. So now it says -2B plus C equals 3. Okay. Solve for C. No, just solve for C.
C equals 3 over.
You're making it way too complicated. How do I get C by itself? Just add 2B, right? That means if you see the letter C, you can now write. Now look at the last statement. What does it say? What does the last statement say? It says A, but I know A is. Then it says minus C, and I know what C is. C is 2B. So all I'm doing is taking that last statement right here and writing the information I have. It says if you have A, you write -B. I got A, so I'm going to write -B. It says here you have -C, and it says if you have C, you write 2B plus 3. That's what I did. Distribute the negative sign. And now I only have B's, and now I can solve for B's. That's going to give me, add the 3 to the other side, and you get -2. I didn't say it was going to be a friendly answer. And you get 2/3. So B is 2/3, an ugly answer, no doubt. So now I know what B is. B is 2/3. Okay. I didn't erase this answer. If B is 2/3, then what's A? If B is 2/3, then what's A? -2/3. All I'm doing is taking that last statement right there and substituting 2/3 in for B. Now I'm only left with C, and I can get that either from, I don't know, the middle one or the bottom one. Which one you want? The bottom one. Okay, so A is -2/3. Okay, that's not friendly, but let's see, negative 2/3. I don't know if that's how I did it. Negative 2/3 minus c is equal to -5. Yes? Is that how I did it, or did I do it a different way? No, that's what I did as well. Okay. Sometimes I may have used the top one. Okay. Add 2/3 to both sides. Multiply by a negative. You agree we get an answer? Common denominator is 3, so that's -15/3, right? -5 would be -15/3. Add 2/3 to -15, and you get -13/3, and that's what negative c is. Therefore, c is 13/3. It's not friendly, but it is what it is. What's our last step?
Lay it back in.
And it's the ugliest fraction you've ever seen in your life. Because look at our answers. It says A is, and this says B is 2/3, but it's times x plus c, and c is 13/3. So it's going to be a really ugly answer.
The fractions on top of.
You can't. That's the answer. That's why there's only 5 of these tonight for homework. We'll do 3 of these. 3 of these. Okay? Yep. Sure. Anybody? Anybody? Upset? Upset? Okay. All right. I'm going to say that was bad. I mean, Abby said not too bad. Let's do an easy one so we can build our confidence back up. Yeah? And then we'll do it. We'll finish on a more challenging one. All right, here we go. Little step 1. And it's just the denominator. So factor the denominator. Times x times. What are you factoring the bottom with?
X times x squared plus
So close.
plus
Plus 1. Okay. Yes, everybody? Now I move the x cubed to the other side when I factored, right? So if you wrote 1 plus x squared, same answer, right?
because you can just take out the.
Yeah. Is x squared plus 1 factorable? No. Right, so that's it. And notice I don't have a linear term now. I got a squared term inside. I also don't have any repeats, right? We'll do one with repeats next one, I think. Okay, cool. So let's see. I got to write the partial fraction. So that's going to be my a. This is going to be my bx plus c because it's a nonlinear term. Everybody with me? Clear the fraction. So I'm multiplying everything times. I don't like to think of it as multiplying by x plus x cubed because you're kind of loose. I'm thinking about it as multiplying by x times x squared plus 1 because that's the factored form. So this one's missing nothing, so it goes away. What's this one missing? And what's this one missing? Okay. See what it did? Okay.
Ax squared plus bx.
She's already trying to do multiple steps in her head. We're gonna, nothing wrong with that. We're distribute the a and distribute the x. So ax squared plus a plus bx squared plus cx. Yeah? Stop me if I'm going too fast. Now group together your x squares, your x's, and your constants. And then factor out those constants. So that would be a plus b times, and then that would be
C.
c times x. There's nothing to factor out there. Plus a. There we go. Cool. Watch how much easier this one is. Hey, this says x squared. That means a plus b must equal. Yeah? Everybody else? Why is this turning into a Seth Abbey show every day?
Sorry.
That means c must immediately equal. C must equal. Hey, this is c times x. Look on the other side. -7. No work needed at all. And that must mean a is equal to. Wow, that was easy. In fact, the only thing I now have to need to solve for is b. Right? I know that a plus b is equal to 5. I know that c is equal to -7 and a is equal to -6. So the only thing I need to solve for is b. Take the top and let a be. A is equal to, plug that into the top and you get equals 5 and solve that. B equals 11. That was easy. Take these values, toss them into our original partial fraction, and you're done. That was our original partial fraction in red. The values here are in yellow, and there you're done. Remember, if there's a negative involved, they like to put the negative to the front. If it's one thing, that's why this fraction 6 over x is now negative 6 over x, but we didn't do that with the c value. C value is just minus 7. Yes? Most of the ones tonight for homework are like that one. Okay. They kind of just fall into place really quickly. All right, one more. Hey, look, they were nice to you. It's already factored. Any nonlinear terms? Yep, so this is going to be flavor number 3. So this is going to be, if you make this your first factor, this is going to be ax plus b. And this is going to be your c. I need to have an x attached to that. Right. You also could write the x plus 3 first if you'd rather there be an a. Doesn't really matter. Cool? All right. You've done this now a bunch of times. This is the common denominator. What's this one missing? What's this one missing? All right, let's multiply. Ax times x, ax times 3, b times x, b times 3. Strip the c to the inside. Group your x squares together and factor out the constants. A plus c times x squared. Now do your x's. So b plus 3a. Right? They were probably going to write 3a plus b, but you could write it the way you said it. And then last with the constants. I think it's just 3 plus 2. Or b plus c. Sorry, what's that? Cool? Anybody lost? Okay, so what's a plus c? What's 3a plus b? And what's 3b plus 2c? Okay. This is everything you just said. Yes? Okay. Now you got to make some choices. Do you want to solve for A or you want to solve for C? Pick one. You solve for A, removing the C to the other side, it would say
5 minus.
A is equal to 5 minus C, right? I'm going to throw that answer into that. The issue is that what I just circled in red doesn't have an A, but it does have a C. So if you were going to do it your way, then you're going to be solving for the middle one for A. And then you'd have to take the last one, solve for B. I'm going to choose this one because, as you'll see, I won't wind up with ugly fractions. So I'm going to solve for C, not A. So C is, subtract the A, 5 minus A. So the last one, I can replace that C with parentheses 5 minus A. But then I need B. So then I need to go to the middle one and solve for B. So I can plug it into the bottom one. So I'm going to go to the middle one, solve for B. See what it did? Now I know what C is. Now I know what B is. I can take those two values. C is 5 minus A. B is 10 minus 3A and toss them into the bottom one in red. So it's going to be 3 times parentheses 10 minus 3A plus 2 times parentheses 5 minus A. And that all equals 7. And now all I'm left with is A. Now it's just a trivial matter of doing a little bit of algebra. So that's going to be 30 minus 9A plus 10 minus 2A is equal to 7. I got negative 11A's and 40, right? Subtract 40, you get 3. Therefore, A is positive 3. If A is positive 3, I go to the top here and say that C is equal to 2. Right, all I'm doing is going to the top there. Oh, it looks like I'm going to B next. I would have done that next. I'm not sure why I want you to do here, but we can do this. Okay. Let's solve for B. Oh, I know why, because we want to go A, B, C in order. Okay, that's silly. Okay, so A is 3. So that would be 10 minus 9, which is, oh, that was easy. Now we can do C. 5 minus 3 is 2. So I was just doing them in order. That seems kind of silly. Final answer, we substitute in for our original partial fraction, that one right there. A is 3, B is 1, C is 2, and we're done. Did we do one with repeats? Ooh, they are tough, right? They are tough. They're tough. All right. We'll do one with repeats and that'll be it. Hey, how do I know this one has repeats? How do we know this one has repeats?
Because there's an exponent.
On the outside. The exponent has to be on the outside for it to be a repeats. Okay. But on the inside, I have, look, a nonlinear term, x squared. So this is the worst of both worlds, so to speak. So I do have repeats. So what are the factors? X squared plus 4 and x squared plus 4 quantity squared. Those are your two factors. And both of them, look, both of them have nonlinear terms. That means both of them are going to get that ax plus b treatment. So my first fraction is going to be ax plus b, and my second fraction is going to be cx plus d when I write my partial fraction. The rest is just exactly what we did before. Am I going too fast? I feel like I'm going fast. Okay. We're going to clear the fraction. What's the middle term missing? An x squared plus 4, right? And unfortunately, we got to do that math. Let's see. Ax times x squared would be x cubed. Ax times 4 is 4ax. B times x squared, bx squared, and b times 4, 4b. And we've done this a whole bunch of times now. Guess what a is immediately? Guess what a is immediately? A is 1. Do you see that? Look, there's an x cubed, and what's in front of it is a 1, so therefore there's only one x cubed up here. That means a has to be the value 1. Okay? So even before I group things together, I only saw one x cubed. I can immediately determine a is 1. Hey, x squared, there's only one of them, and it's b. That means b is also 1. You see where I'm getting that from? In fact, the only one I got to do some thoughts are the linear terms x and the constant term. Hey, look on the left side. Do we even have a linear term? Is there a linear term on the left side? Well, that means that 4a plus c must equal 0. And lastly, 4b plus d must also equal, there's no constant term, 0. So a is 1, b is 1. 4a plus c must equal 0, and 4b plus d must equal 0. Is that too quick? We follow the logic? Now just do some substitutions. What's c going to be equal to? -4. Why? Because if a is 1, you get 4 plus c is equal to 0. In other words, c must be equal to -4. What's d going to be equal to? -4 as well. All I'm doing is taking that a and that b value, substituting it in for those last two equations, that 4a plus c and that 4b plus d. That was pretty straightforward and easy. Like I said, most kids will grow when they hear partial fractions, and it ain't that bad. It algebraically, it's a whole lot of work, but like the logic behind it is pretty straightforward and sweet. If you were wondering, could we have done substitution? We go way back to this step right here. Could we have done substitution for this? Well, we would like this x to be -4, right? So that it would make this go to 0. The problem is the x is being squared, so no matter, we're never going to get a negative there. So this is one where we couldn't even do one of those substitution things.
Unless you plug x in as 0.
If we plug x in for 0, it's going to make the c go away, but it's going to make the a go away. But I'm still going to be left with b and d, and you can't solve for two unknowns. You can only solve for one unknown. So this one is one where we actually had to use this technique. And I'll just say, this is the preferred technique, even though I showed you a substitution one as well. And you're simply going to have to trust that this made our life easier in calculus. Questions on anything we did? Cool? I got one more if you want it. Okay, I'll do number 19. Ish, you're just going to hear verbally what we're doing. Read it. X squared plus 1. Okay. All right, you're on. Linear or nonlinear? Nonlinear. How many factors? 2. The only thing you got to ask yourself, can this one be factored? X squared plus 1 can be factored? No. So it's got 2. So this is going to equal to A over X, right? My first factor, plus nonlinear X squared. So BX plus C over X squared plus 1. Yes? All right. Next step. Clear the fraction. Okay. Clear the fraction, well, that's just plain old 1. What are we missing? So that's A times X squared plus 1. And this one is missing an X. Very good. Distribute. Group. We got any X's? Yep, 1. Plus A. And that all equals 1. Well, guess what A plus B must equal? Is there any X squared over here? Well, it must mean it equals 0. Guess what C must equal? And A must equal 1. Okay. So what's the only letter we're missing? On your B. But we know A is 1. So B is equal to, take this answer, and this answer, toss them into that and you're done.
Off information for Monday.
Oh, cool. Sweet.
Times, certification,
Perfect.
address.
Perfect. Leaf, you got your phone?
Um,
Go get your phone. We'll give you a copy of this.
It's really cheap. Everybody else charges a lot. He's charging $15 a kid.
Well, that's good.
That's what I said. I'm like, JV, absolutely, I'll take that.
In fact, I might show up with a dress.
Just the play.
$15.
They
Wait.
said there-
I'm recording that. That's on. Oh, man.
They said there may not be enough golf carts for coaches.
That's fine. That's fine. I walk anyway.
Yeah, that's what I figured.
I'll just bring a bag so I can carry lunch or something like that. All right, that's it ish.
And you're in the system for I want to make her.
Do you want me to plug her in? Yeah.
You should be able to.
Okay, I'll do it.